In the lesson today, we are going to introduce logarithms and logarithmic function. We will see how logarithms and exponents are inverse to each other, in the same way as addition and subtraction are, or multiplication and division are. We previously met the exponential function, and its form was f of x equals a times b to the power of x. Like, for example, f of x equals 3 times 2 to the power of x. Or f of x, let me call it f1, f2, they are different, equals 4 times 1 over 3 to the power of x. And we met this function in the context of geometric progressions. You might want to go back and revise this concept. However, we are going to apart a bit from it, and we are going to look at exponential functions and in terms of the growth. The graphs of such functions were, and you might want to pause the movie and try it yourself before I draw it, y equals 3 times 2 to the power of x, and I start with 2 to the power of x, and I do then a vertical stretch by a factor of 3. In this case, when the base of the exponent is negative, the function is decreasing, so this is y equals 1 over 3 to the power of x, and then after a vertical stretch by a factor of 4, our graph will look like this. In the case when the base of the exponent is bigger than 1, the function is increasing, we'll always have this shape. In the case when the base is between 0 and 1, the function is decreasing, meaning when you draw it from the left to right, you descend, you go down. Of course, we will apply always transformation of functions, like for example, if we have f3 of x equals negative 3 times 1 over 4 to the power of x. When we draw it, we know that 1 over 4 to the power of x is descending. 3 means applying a vertical stretch. And minus 3 minus y, it's a reflection on the x-axis. So your final function will look like this. It might happen that you have a 2 here, meaning that it's an horizontal stretch by a factor of 1 over 2. And therefore you'll stretch it closer to the y-axis. You can't really see very much in this shape. This slide was a bit of revision from the AS course. So, how about the new concept of logarithms? Let's start with the function f of x equals 2 to the power of x. The graph of this function looks like this. It is an increasing function. As you see, it is a one-to-one function, so it will have an inverse. The inverse is symmetric with a function on the line y equals x we learned last year. So the graph of the inverse will look pretty much like this. They are reflected. The graph is called logarithm in the base 2 of x. And it's an inverse of 2 to the power of x. Let's see what does it really mean. Let us look at, for example, 2 to the power of 3, which is 8. So on y equals 2 to the power of x, we have the point 3. When x is 3, y is 8. On the graph of log, because it's symmetric on y equals x, we are going to have the point 8, 3. Therefore, log in the base 2 of 8 is 3. Pause a bit and think of this concept. Now I can say directly log in the base 2 of 8 is 3 because 2 to the power of 3 is 8. What is it then? Log, for example, in the base 3 of 9. So 3 to which power is 9? 3 square is 9. What is log in the base 10 of 1000? 10 to what power is 1000? 10 to the power of 3 is 1000. This is how logarithms are introduced. Now I'd like you to stop, go back and make notes that will make sense for you and will help you revise later.